So this question here wants the definition of the instantaneous velocity. And so before we look at the choices, what we want to pick our own brain first. And the instantaneous velocity is the rate of change in displacement. Or, as I taught you, the rate of change of position. This is actually the more true definition. So, rate of change of displacement. So when we go to look at the choices now, we're going to look at all of them. Notice they use the word distance. That should be kind of a flag. We've got velocity and distance. The next one is distance. And then we have displacement and displacement. And so displacement over time versus the rate of change of displacement at time, it is d. And let me show you the reason why that can't be the case. And so if we have displacement, delta x, and t, if we have this, the red curve, and we have the blue curve, well, if we have, with the red curve, if we picked a point on it, this point has the coordinates of, say, let's say 0 or 4, 0, 4, 4. And this has the coordinates of 0, 0. And we want to find the rate of change. That's the slope, delta y over delta x, which is delta x over delta t. We have 4 minus 0 over 4 minus 0. So we end up with a slope of 1, a velocity of 1, and that's because these are zeros. We could have just done delta x over t, and we would have gotten 4 over 4 or 1, the same answer. But the reason we got the same answer is because the initial positions, the second numbers, the initial position, the initial coordinates are 0. That's why that works. If we were to do the same thing up here, clearly these two are parallel to each other, so they should have the same slope. Well, this one is 4, 8, and this one is 0, 4. Now we can see they have the same slope, should give the same velocity. But if we just took delta x over t, we would have 4 over, 8 over 8 over 4, which is 2. But if we do delta x over delta t, or delta y over delta x, we're left with 8 minus 4 over 4 minus 0. Well, that will give us the 4 over 4 to give us the same one. But we can't just take the distance and divide it by the time. So you have to be careful about that. And it comes back to that initial definition of what it is in words. The rate of change of displacement at any moment time, t.